Ukraine just exposed the big lie behind Russian power. It was 5:47 a.m. in Moscow when that lie started to crumble. Tiny points of light, barely noticeable, showed up on the radars of the planet's most feared defense systems. Operators stared at their screens with growing confusion. Those objects didn't follow any known pattern. They didn't look like missiles. They weren't enemy jets. They were too small, too fast, and there were lots of them. What happened that morning wasn't just a military attack. It was the exact moment the world found out that the invincible Russian shield was actually a huge sieve. The operation destroyed more than just aircraft. It destroyed myths, but the real damage was to Russian pride. And now the question terrifying not just Moscow, but every military power in the world is, if billion-dollar systems can be neutralized by devices costing $400, what other military truths are just expensive illusions? For decades, the military paradigm was based on a simple logic. Whoever had the most expensive and technologically advanced systems would dominate the battlefield. Countries poured fortunes into supersonic jets, armored tanks, and air defense systems costing hundreds of millions of dollars. Russia, following that philosophy, developed the S-400 Triumph, considered one of the most sophisticated air defense networks in the world. The S-400 sold to countries like China, India, and Turkey for about $200 million per battery, was presented as an impenetrable shield, capable of tracking targets beyond 400 kilometers and intercepting everything from cruise missiles to ballistic projectiles. The system seemed to represent the future of military defense. But there was a fundamental flaw few imagined. Its design was based on last century's threats. While Russian engineers designed systems to fight combat jets flying at high altitudes and intercontinental missiles, a silent revolution was happening in garages and small factories around the world. Commercial drones, initially made for photography and entertainment, were being adapted for military purposes at a fraction of the cost of traditional systems. Ukraine, forced by necessity and limited resources, became a pioneer in this transformation. Facing an enemy with conventional numerical and technological superiority, the Ukrainians had to innovate or perish. The answer came in the form of modified FPV drones, small devices originally created for racing and aerial acrobatics, but adapted to carry explosives and execute kamikaze missions with surgical precision. These $400 warriors, as they were nicknamed, completely changed the military equation. While a single S-400 interceptor missile costs between $3 and $4 million, a Ukrainian FPV drone costs less than $500 to produce. This economic gap created an impossible equation for the defenders. For every drone shot down, the cost was 8,000 times higher than the damage caused to the attacker. But the real genius wasn't just the low cost. The Ukrainians discovered that swarms of small, agile drones could overwhelm any defense system, no matter how advanced. The concept is similar to a swarm of bees attacking a bear. Individually, each bee is insignificant, but together they can bring down a much larger predator. The spiderweb operation wasn't just an attack. It was a masterpiece of strategic planning and technological innovation. For over a year, Ukraine's Security Service, SBU, developed a three-phase plan that looked like it came straight out of a spy movie. The first phase involved silently infiltrating drone components into Russian territory. Using modified shipping containers and fake documents, civilian trucks transported parts and equipment through military checkpoints without raising suspicion. These special containers, equipped with remotely controlled retractable roofs, were strategically positioned near Russian air bases. In the second phase, specialized teams assembled and tested the drones at secret locations, each equipped with AI-based navigation systems. These systems could automatically recalculate routes when GPS signals were blocked, a crucial ability in the high electronic interference environments typical of modern battlefields. The operation's success exposed fundamental vulnerabilities in traditional defense systems. The S-400, despite all its sophistication, was designed for a different military reality. Its main radars efficiently monitor threats at medium and high altitudes, but lose accuracy with objects flying less than 50 meters above the ground, exactly the preferred altitude of FPV drones. Moreover, the system's reaction time, spinning the radar, identifying the threat, locking the target, and firing an interceptor, takes between 15 and 30 seconds. For ballistic missiles flying predictable trajectories, this time is adequate. For swarms of small drones flying low and constantly changing direction, it's an eternity. The saturation tactic proved devastatingly effective. Each S S-400 battery has limited capacity for multiple rapid-fire shots, but can't process hundreds of small, agile targets at once. While the system wasted its expensive interceptor missiles shooting down some drones, most of the swarm advanced undetected, like floodwaters bypassing a dam. The Russians tried to quickly reposition their mobile launchers, but this maneuver created vulnerability windows that Ukrainians exploited with surgical precision. During those brief relocation moments, the systems became temporarily blind, allowing more drones to penetrate defenses. One of the most sophisticated tactics used by Ukrainians was the deployment of decoy drones to neutralize radar systems. These small, sacrificed drones deliberately approached radar stations to force their activation. Once active, the radar beam acted like a beacon in the ocean, revealing the exact emitter position to precision missiles waiting for the right moment to strike. American ATACMS missiles, with a range of 300 kilometers, were used to eliminate these detection sources as soon as they were located. At the same time, Ukrainian electronic warfare systems like the advanced EDR neutralized Russian attempts to regain electromagnetic spectrum control through signal spoofing and broadband interference. Russia had high hopes for the S-500 Prometheus, announced in 2021 as the successor to the S-400, promising revolutionary capabilities, including intercepting hypersonic targets and even satellites in low orbit at 100 kilometers altitude. The system was touted as the ultimate answer to future threats. 8 units were planned by 2025, but only one was deployed on the strategic Crimean Peninsula to protect the vital Kerch Bridge. In April 2025, the system faced its first real test against ATACMS missiles. The result was disappointing. The S-500 completely failed to lock on and neutralize the threats, showing it was still a prototype with software and hardware adjustments in progress. This failure revealed a crucial lesson about modern military development. Extremely complex and expensive systems can become easy targets if not properly tested against adversaries thinking unconventionally. Russian engineering had created a technological masterpiece to fight imaginary threats, while real threats flew just meters above the ground at a fraction of the cost. But the real game changer in the Ukrainian operation wasn't just the low drone cost, but the integration of artificial intelligence in every aspect of the mission. Platforms like Palantir Foundry, combined with locally developed solutions like the Ukrainian Drone OS, processed massive volumes of data in real time. Machine learning algorithms, trained with thousands of hours of satellite images, reconnaissance drone feeds, and even social media information, identified troop movement patterns and ideal points for launching attacks. This processing ability let Ukrainians anticipate Russian moves and adjust tactics dynamically. On the drones themselves, embedded AI systems enabled autonomous flight even in environments where GPS signals were blocked or jammed. Depth sensors and computer vision allowed devices to distinguish buildings, obstacles, and targets, reducing navigation errors by over 70% and boosting impact success rates to an impressive 85%. Russia's failure in the spiderweb operation wasn't just about Ukrainian technological superiority, but the result of deep structural problems affecting the entire Russian military-industrial complex. Decades of corruption, mismanagement, and lack of adaptation created vulnerabilities that $400 drones exploited devastatingly. International sanctions caused critical bottlenecks in Russia's supply chain. Missile factories and electronic component plants suffer from shortages of advanced semiconductors and specialized materials, delaying production of essential parts for defense systems. It's estimated that S-400 interceptor production dropped by 60% since 2022 due to these limitations. But the real problem in Russia's military system is the internal corruption infecting every level of hierarchy. Russia systematically eliminated independent media and NGOs, restricted access to budget spending information and government contracts, making public oversight almost impossible, and leading to rampant corruption at all levels of governance. The numbers are shocking. In 2024, a series of high-level arrests exposed the extent of the problem. On May 22, 2024, Lieutenant General Vadim Shamarin, chief of the Armed Forces Main Communications Directorate, was arrested on bribery suspicions, followed by Vontorg CEO Vladimir Pavlov in July, accused of large-scale fraud. These aren't isolated cases. They represent the tip of the iceberg of a system where stealing military resources became more profitable than defending them. Moscow pours colossal sums into its arms industry, but endemic corruption and component shortages mean it can't meet its military's needs. Imagine the absurdity. Billions invested in defense systems while those responsible for maintenance systematically steal parts, fuel, and ammunition to sell on the black market. Russian intelligence analysis made an even more fundamental mistake. drastically underestimating Ukrainian adaptation and innovation capacity. Trapped in a 20th century military mindset, Russian commanders believed the conflict would return to conventional confrontation between large, armored formations. Meanwhile, they ignored clear signs that a silent revolution in drone production was happening right under their noses. Ukrainian companies that used to make toys, home electronics, and smartphone components converted their production lines to military drones in weeks. This agility and adaptability sharply contrast with Russian military bureaucracy, where changes take years to implement and are often sabotaged by corrupt interests. The result of this perfect storm of structural problems was that when 117 small drones showed up on Russian radars that June morning, the system simply couldn't respond properly. Not due to technological limits, but because decades of mismanagement, corruption, and external dependence had created a giant with feet of clay. Impressive on the outside, but rotten inside. The spiderweb operation was just the prelude to a much bigger transformation shaping the future of military strategy. We're entering the era of software armies, where victories and defeats will first be decided on artificial intelligence servers before any projectile is fired. Machine learning algorithms already identify targets faster than human operators. Automated decision-making systems process information from thousands of sensors simultaneously, creating superhuman situational awareness. In a few years, we'll see conflicts where data processing speed matters more than combat aircraft speed. Autonomous drone swarms, operating with collective intelligence similar to social insects, will become the dominant force on future battlefields. Each unit can be simple and cheap individually, but collectively, these swarms will show complex emergent behaviors, real-time adaptation, collective learning, and distributed decision-making. The line between human fighters and autonomous systems will keep blurring. When future military historians look back at the spiderweb operation, they'll probably see it as a turning point comparable to the first use of gunpowder in combat or the introduction of military aircraft in the First World War. It was the moment the world realized the era of supremacy of expensive, complex military systems had ended. The real lesson of this historic operation isn't about specific technology, but about adaptability and innovative thinking. Ukrainians won not because they had superior weapons, but because they thought differently. They questioned basic assumptions about how conflicts should be fought and found creative solutions to seemingly impossible problems. This mindset of constant innovation will be the ultimate competitive edge in future conflicts. Nations that combine human creativity with emerging technological capabilities will dominate those relying only on traditional numerical or technological superiority. The question we should ask isn't whether this technological revolution will permanently redefine the battlefield. It already has. The real question is, how will our society's militaries and leaders adapt to this new reality where $400 can defeat 400 million? The military future is already here, flying low and costing little, and it's changing everything.